Now that we have a working demo, we need to make it safe and secure to deploy in the real world. The way we do that for Firestore is by defining rules on the Rules tab in the Firebase console. Without rules, anybody can read or write any value in your database, which means your users could modify each other's content, update the heart counts, delete content, and all kinds of other bad stuff. Rules have their own syntax, and I have an entire course breaking that down in detail. Because if you're just getting started with Firebase rules, this video might be a little intimidating. You can write your rules directly in the console here, but I'll be writing mine in the IDE just because that gives us a little better readability. I'll show you the code for each one of these rules and break down exactly what it does. The first rule matches the root collection of posts, but you might be wondering, we don't even have a root collection of posts. The reason we need this rule is because we're running a collection group query that grabs all of the sub-collections nested under the user. And when you're running a collection group, you need to have a root rule like I'm showing here. Now, all of our subsequent rules are going to break the logic down into functions. So let's go ahead and review the different paths that we need to secure. We have the user document, which anybody can read, but in order to create it, you must have a valid user. And same thing with the username. Anybody can read it, but when creating, it needs to be a valid username. Now, when creating a post, things get a little more complex. To create a post, it needs to be a valid post, but when updating a post, we have slightly different rules, and we also have a situation where a user can increment the heart count on a post, so we need a separate function to handle that logic, and we have them separated by an OR operator. When deleting a post, the only thing we need to verify is that the request auth user ID, or the current user, equals the user ID variable in the path itself. Then our final collection is the hearts collection nested under posts. In order to write to it, you must own that heart, which we can do by checking the request auth user ID of the current user to the ID of the heart document. That gives us an outline for our security rules. Now let's take a look at the actual functions that need to be implemented to handle that logic. Inside of functions, we can define variables for different conditions. A user is considered the owner of a document if their request auth user ID equals the user ID in the path. Now, if you remember from our custom usernames video, in order to create a user document, we also need to create a username document at the exact same time with a batch write. Firestore rules have a special function called existAfter that allow you to grab a document from the database as if it were already created in the batch write. And that's what we need to do in this case to make sure that the username document is being created at the same time. That gives us two conditions, is owner and created valid username, which we can return from the function to ensure that they both return true in order for this rule to pass and allow the operation to succeed in the database. We should also validate the username using similar logic. We'll make sure that it is owned by the current user, and then we'll also validate its length by checking the size of the string value and making sure that it fits between 3 and 15 characters. Like existAfter, there's also a function called getAfter that allows us to retrieve the document after the batch write has hypothetically been finished. What we want to do is make sure that the username equals the username on the user document so the user can't set up a username that is mismatched. Then we'll go ahead and return those three conditions from the function. Now let's move on to the create post function. There's likely a lot of different validation that you want to do for your post based on the type of content you're saving there. First, we'll make sure the user owns the document. Then we also want to check the timestamp to make sure that the request time equals the created at timestamp on the document. This ensures the user can't modify the created at timestamp on their own. Then we can also validate the content format, like we can make sure the size is less than 20,000 characters and make sure that the initial heart count is always set to 0. Another thing we might want to do is make sure the username matches the current user, but that lives in a different document. So we can use the get function built into Firebase rules to retrieve the document of the current user and make sure that the username matches the username saved on this document. Now, when updating a post, things are a little different because we likely only want to update a certain subset of fields. Now, we have many of the same validations like whether or not the user owns the document, the timestamp, and the content format. But there are certain fields that we do not want the user to update, like the username, user ID, and the heart count. We can forbid certain fields from being updated by checking the diff from the request resource data to the actual resource data in the database. Then use the affected keys method to ensure that none of the fields included in this array are included on the update. and that gives us a safe way for the user to update the document. And that brings us to our final and most complex rule, can increment the hearts, which defines who can increment the heart count on a post document. This one is a little scary because we're allowing any user to update another user's post document. The first thing we'll validate in the function is that it only has the heart count field. And again, we can check the diff from the request resource data to the resource data, this time making sure that it has only the heart count. Now, this rule is being applied to the post document, so we need to also get the heart document after it exists from the batch write and as it exists currently. Having access to those two different states of the heart document allows us to determine whether a heart document was added or removed. Now from there, we need to calculate the actual value that the heart count is changing, which should either be 1 or -1 if it's a valid change. Then when we return our conditions, we can use a ternary operator here to check if the count change equals 1. If so, we want to validate that the heart document was added. Otherwise, the heart document should be removed. And that provides us with a safe way to increment the heart count when the user clicks the heart button. That takes care of our security rules for now. You could modify these with additional validations and things like that, but it gives us a pretty good starting point. You can copy and paste the rules directly into the Firebase console and save them there. Or if you have them locally in your IDE, you can use the Firebase CLI tools to upload them from the command line.